Question overview. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Today we're tackling a critical security challenge that every cloud architect faces: how to securely connect applications to databases while following the principle of least privilege. As a network engineer, you need to design a secure method for compute engine applications to access a Cloud SQL database. The key here is least privilege. We want to grant only the minimum permissions necessary. This question tests your understanding of Google Cloud's security best practices, particularly around secrets management and IAM. Let's analyze each option to find the most secure solution. Understanding least privilege. Before diving into the options, let's clarify what least privilege means in practice. It's a fundamental security principle where users, applications, and systems are given only the minimum levels of access needed to perform their functions. In our context, this means the application should only be able to read the database password when needed and access only the specific Cloud SQL instance it requires, nothing more. The diagram shows the access patterns we need to consider. Notice how we need to protect both the password storage and the database access. A compromise in either area could lead to a security breach. Remember, in cloud security, we assume breach. We design systems so that even if one component is compromised, the blast radius is limited. Option 1. Hard-coded password. Let's start with the first option: hard-coding the password in the application. Oh boy, where do I begin? This is essentially the what not to do example in any security training. When you hard-code credentials, they become part of your application code. This means they're visible to anyone who can access your code repository, deployment artifacts, or the instance itself. I've seen real breaches happen this way. Developers accidentally commit credentials to GitHub, or an attacker gains access to an instance and simply reads the configuration files. It's like leaving your house key under the doormat, convenient but terribly insecure. This approach violates multiple security principles: no separation of concerns, no rotation capability, and maximum exposure. It's the opposite of least privilege. Option 2. IAM with default service account. Option 2 suggests storing the password in IAM and using the default service account. This is a step in the right direction but has significant issues. First, let me clarify. IAM doesn't actually store passwords. This option likely means using the default service account to authenticate to Cloud SQL directly, which is possible with Cloud SQL's IAM authentication feature. The problem? Default service accounts are overly permissioned. The Compute Engine default service account has project-wide permissions, including the ability to access all cloud APIs. This violates least privilege. Additionally, using default service accounts is considered an anti-pattern. Google themselves recommend creating custom service accounts with minimal permissions. It's like using the admin account for everyday tasks, unnecessary and risky. Option 3. Private storage bucket. Storing the password in a cloud storage bucket. This is getting warmer but still has issues. While it's better than hardcoding, cloud storage isn't designed for secrets management. Yes, you can encrypt objects in cloud storage and control access with IAM, but there are several problems. First, cloud storage doesn't provide automatic rotation capabilities. Second, access logs for cloud storage aren't as detailed as purpose-built secrets management tools. Most importantly, using cloud storage for secrets is like using a filing cabinet to store your passwords. It might work, but there are purpose-built safes, secret managers, that do the job much better. From a least privilege perspective, you'd need to grant storage object viewer permissions, which could potentially include access to other objects in the bucket if not carefully configured. Option 4. Secret Manager with KMS. Now we're talking. This option represents Google Cloud's recommended approach for secrets management. Let me explain why this is the gold standard. Secret Manager is purpose-built for storing sensitive data like passwords. It provides automatic encryption at rest using Cloud KMS, detailed audit logging, and built-in versioning and rotation capabilities. The beauty of this approach is the granular permission model. You create a custom service account that has exactly 3 permissions: access to Secret Manager to read the password, access to KMS to decrypt it, and access to Cloud SQL to connect. Nothing more. This perfectly embodies least privilege. Even if the service account is compromised, an attacker can only access this specific secret and database. The blast radius is minimal. Plus, you get full audit trails of who accessed what and when. Security Analysis Comparison. Let's compare all options from a security perspective. I'm evaluating each option across multiple security dimensions that matter in production environments. Notice how option 4, Secret Manager, scores highest across all categories. It's not just about storing the password securely. It's about the entire lifecycle: creation, storage, access, rotation, and auditing. The comparison clearly shows why purpose-built tools matter. While you could technically make options 2 or 3 work with enough effort, why would you? It's like building your own door lock when professional-grade locks already exist. In my experience implementing these patterns, the Secret Manager approach also scales better. As you add more secrets and applications, the management overhead remains low. Implementation architecture. Here's how the complete Secret Manager solution works in practice. This architecture implements defense in depth with multiple security layers. Notice the flow. The application uses its custom service account to authenticate to Secret Manager, retrieves the encrypted password, Cloud KMS automatically decrypts it, and then the application connects to Cloud SQL. Each step is logged and controlled. The beauty is that the password never exists in plaintext on disk. It's only decrypted in memory when needed. If someone takes a snapshot of your disk or gains SSH access, they still can't see the password. This architecture also supports password rotation without application changes. You simply create a new version in Secret Manager, and the application automatically uses it on the next retrieval. Implementation commands. Let me walk you through the exact implementation. These commands set up a production-ready secure connection between your compute engine application and Cloud SQL. First, we create a secret in Secret Manager with the database password. Notice how we're using automatic replication for high availability. Next, we create a custom service account with a descriptive name. This follows the principle of accountability. We know exactly what this account is for. Then comes the crucial part: granting minimal permissions. We give access only to this specific secret, not all secrets. The service account can access the secret and connect to the database, nothing else. Finally, we update the application to use the Secret Manager client library. The code is clean, auditable, and the password is never hard-coded. This is how secure applications are built. Summary and best practices. Let's wrap up with the key takeaways. The clear winner is option 4. Secret Manager with Cloud KMS and custom service accounts. This isn't just the most secure option. It's the easiest to manage long-term. Remember these principles. Never hard-code secrets. Always use purpose-built tools for their intended purpose. Create custom service accounts with minimal permissions. Enable audit logging for compliance. In production, I also recommend implementing secret rotation policies, using VPC service controls for additional network security, and regularly reviewing access logs. Security isn't about making things complex, it's about using the right tools correctly. Secret Manager makes security both robust and manageable. That's the kind of solution that lets you sleep well at night. Thank you for your attendance. Please consider subscribing to the channel.